What? Oh, all right, guys. So anybody who's here right now have any questions from homework stuff? I'm going to mute everybody. Unmute yourself if you have something you need to say. Nope. Anybody? Nobody? Any questions from homework stuff? All right. I'm going to come out of the sea. Oh, holy macarones. I guess I didn't really need to do that. So let's do this. I have another sheet that I just posted. Did I post it? Yes. I posted it to Canvas. I'm going to be sharing it with you guys. So you can go there later if you want to get this. I added it in the same place on Pages where the handout for 7.2 is. Okay, man, my hair is not crazy enough. There we go. All right. Okay, let me see. Somebody else just came in. Good, good, good. What is going on over there? Oh, she's erased. All right. So if there's no questions from homework, everybody's good. Maybe I can get some of that homework, some of that sweet, sweet homework. If I can get some, that'd be great. All right. So let me share this with you guys.
I actually have something to say about that.
Who's this?
It's me, Veronica. Hi.
Hey, what's up?
So due to the fact my computer's not working, I haven't been able to do my homework because whenever I try to turn my homework to PDF, my phone won't let me set it on Canvas. It's weird.
Oh, so your phone doesn't let you upload it to Canvas?
Basically.
Okay, so you've been sending me email. You've been sending me homework over email too, right?
Yep. If you saw that, I hope.
And I think I probably at one point said, hey, could you please put this in Canvas? And you could just say, I'm really sorry, there's technical issues, and then I'll deal with it. It's okay.
Yeah, because hopefully I will get it fixed today. That way I can do all the rest of the homework.
In the meantime, if anybody has technical issues that keeps them from doing exactly what I ask, then do what you can and let me know. And then obviously I'm going to work with you because this is not the way any of us wanted this to be. I like it. Anybody else have issues or concerns or questions or no? Okay. I'm sure that's probably a yes, but we don't have to bring it up now. Oh, what's up?
Okay, number chapter 7.2, number 120. I can't give you that question.
7.2, number 20?
Yes, 120.
120. Ooh. 120. Where are you, 7.2? There you are. So 120 says, where are you? Oh, m squared plus 29m plus 120. Okay, let's see.
Okay, how we got, 120. Now I know the m is 2m. We have here 2 m's, 2 square, m squared, and 24 plus 5 is 29 m, and 120. How we got the 120?
Okay, let me stop you right there. You have to help me. Where did 24 and 5 come from?
Yes.
Where did 24 and 5 come from? You just said 24 and 5. Where did they come from?
The parentheses.
Yeah. All right.
From the
are you looking at the answer and then asking me how they got the answer?
Yes.
Okay,
yes.
Don't do that. Stop. All right. So. All right, guys. This will be a decent little review. What two numbers do you need? So let's start off with this. When the first number is a 1, you can always write down this much. What's going to go right here?
M.
Yes, M. So pretty cool with that. I mean, that's the only way to make m squared is m times m. That's like the first step in foiling, right? So the only thing we don't know is what those numbers are. And what two things do those numbers need to do?
Add to be 29 and multiply to be 120.
Yeah, so always add to be the middle term if this is in order. Add to be the middle coefficient, multiply to be the last one. So how could you do this then? You could start to break 120 up and check each way. So you could do this, 120, oh good. And you say, okay, that's 2 times 60, but 2 plus 60 is not 29. No, 3 times 40, but 3 plus 40 is not 29. And just continue. You'll get there.
24 plus 5 is, you got 29.
You understand how to get those numbers. That's what's important. I don't care what the numbers are that's written down in the answers, but you know how to get those numbers. You could do something like that, or you could say what adds to be 29 and check each one to see if it makes 120. Are you guys with me?
No, I don't understand this question.
Oh, okay, all right. So you have to be, let's back up. Let me put this up here. Let me let this person in. Okay. Let me put the problem way up here. So we discussed last time why it makes sense that the two numbers that complete this answer add to be this and multiply to be this. So does anyone need, it's okay if the answer to this is yes, because we just did this last time. Do you need a refresher on why that's true? Anybody? No? Is everybody all right? Okay. It's okay if the answer is yes, it's fine. But no, okay, good. So I can assume now that everybody understands why I need those two things to happen. Okay. So I know it's M, like we said earlier. Now, again, I need two numbers that multiply to be 120 and add to be 29. So what I can do to make this simpler, sure, Jeff, is make a list of numbers that multiply to be 120 and then check each one to see what adds to be 29. So effectively, I'm making one thing true and then checking if the other thing is true. Both things have to be true at the same time. So if I start with 120, well, that's 2 times 60, but 2 plus 60 is not 29. Does everybody understand why I can eliminate those? 2 times 60 only makes one thing true. It doesn't make both things true. It's got to make 120 when you multiply, check, and it's got to add to 29. Ah, shit. Yes? No? Purple? I don't know. What was another option for an answer there?
Like we said.
Huh?
Like we said, 2 times 60 is 120.
Sure. But does it also add to be 29? 2 plus 60 is 29? Nope.
No.
There. Okay, good. And now keep going. So that's not the answer yet.
I
3
got
times 40 makes 120. Does it also make 29 when you add them? No. 4 times 30, right? Right? Yes? Yes?
Yeah.
Okay, now.
Yes.
You don't.
Yeah, I forgot the same number.
Okay, now watch. You could, instead of doing that, you could start with 29. Make two numbers that add to 29. Isn't that easier
Yeah.
than products? So sometimes it's easier to start with the middle and say like 20 plus 9 is 29, right? 29, 20 plus 9 is 29. What's 20 times 9? 180. Ah, shit. Sorry, so then you try 23 and 6. Doesn't that make 29? Yep. 23 times 6 is 138. I like this because then it's more like a game. Am I getting closer to what I want? Yes. So I just continue the way I'm going. It's really cool. But at the bottom of everything I'm doing up there is I need two numbers that do two things. Who cares which one happens first? It just has to end up doing both. Add to be this, multiply to be this. And this is where the people that just sort of naturally or whatever reason they are able to play with numbers more, they will have an easier time with this. Is that fair? I don't know. I took art class, started painting for the first time, and then there was somebody who had been painting since they were 2. Was that fair? Who cares? We're just learning. They happen to be a little ahead of me just naturally. Okay. So you have to come up with approaches to get two numbers that do what they're supposed to do. And I've given you a couple of ways to do this. Are there more ways? Oh, hell yeah. Let me give you one little thing. And this is what I think people really need to get over is, sure, I could teach you one way to do this. And that way would suck sometimes. So I try to show you a few different ways. So watch this. 120, like we said, is 2 times 60, isn't it? Right? And isn't 60 6 times 10? So then it's also 12 times 10. Do you see that? So it's kind of like another approach is to play with the factors of the numbers. Isn't 10 5 times 2? Right? And then 12 times 2 is 24 times 5, and that is the answer, like we saw. So is that always the best way to do it? No. Is it better to know multiple ways to approach a problem? Yes. I don't know if anybody really sees what I'm doing there. So 2 times 60 is 120. So if I factor 60 and then recombine factors, I get another way to break up 120. Then if I break up 10 and recombine factors, I get another way to break up 120. That's a beautiful way to figure out what goes into a number, is to start with what you know and then break it down and recombine it. It's like we're weird math geneticists. We're recombining the DNA, which is kind of the way I describe that, because that's the DNA of a problem. All right. I have no idea if that was useful at all. So yeah, 24 and 5 make 120 when you multiply, make 29 when you add. Therefore, that is the answer, right? Is that all right? If you check it, m times m, m squared. M times 5 is 5m, 24 times m is 24m, 5m and 24m is 29m. 24 times 5 is 120. Check. Next. Okay. The lack of interaction disturbs me.
I got it. Thank you.
Okay. Okay. So let's do this. Here we go. Let me share my screen. Oh, scheisse. I don't want to do that. Hold on. Get over there. Okay. No. Okay. Let me try this out. Share the screen. Bam. You should see a factoring sheet, right? Does everybody see a factoring sheet?
Yes.
Okay, thank you. So what I want you to do, let's just focus on these first 3. Let me blow this up. Zoom in. Okay. Can you guys please write down those first 3? I'll give you like a couple minutes to think about it yourself, and then I'll break you up into rooms and let you guys discuss amongst yourselves. Anybody not know what they're supposed to be doing right now? Okay, hopefully everybody's working. I'm gonna have to hope. Sorry, it's probably annoying. Sorry. Let's see. Give you a little more time. Now, when I break you up into groups, if you have the answer, don't just blurt out the answer and say, we're done with this thing. Try to check with each other's reasoning. How did you get there? All right. Does anybody not have those written down at least? Hopefully everybody's got those written down. I'm going to stop sharing my screen and then break you up. Let me see. Oh, I got 15 people here today. Sweet. All right, I'm going to do, yeah, let's do 3 per room. All right, so when you see the link on your screen, click it. Click it. Go to your room. Good. I'm going to see who's not really here. All right, Nada, Larissa, are you out there? Okay, Larissa's gone. Nada? Lauren? Is that Hayam? You were just there. Hello? Nada? Lauren? Hayam? Okay. Nada? Lauren? You got to come back. Something you got to do. Nada? Lauren? Hello? This is going to be a great part of the recording. Just Jeff yelling at his laptop. Nada! All right. I don't know what happened to you guys. I'm going to count you as absent. Don't like it. Urgh. Lauren, Nada, hello. I'm gonna drop you two. I'm gonna drop you guys from this class, from this meeting. I mean, I don't know. Hey, now it's just Nada. Nada. All right. All right, let's see. Well, this is the exciting part of the video. Sorry, I should have paused it, but I'm about to just close the rooms anyway. Sorry, if you're watching this on YouTube. I'm learning. I apologize. Here, I'll sing a little bit for you.
Why are there so many songs about rainbows?
All right, that's a horrible Kermit. I'm sorry. What about
I see skies are blue, clouds are white. The bright.
okay, I'll stop. I'm gonna close the rooms. Wow. All right. You guys are coming back strong. Let's see. Somebody's in the room by themselves. Oh, there we go. Somebody else is in the room by themselves. They're like, I like it in here. I don't want to go back. All right. Now I'm just missing one person. Come back. All right. This everybody except one person made it back. All right. Hold on, guys. Let's give him a second. He's got 15 more seconds. All right, he'll come back. How'd it go? You guys, anybody absolutely hated that? I mean, you could
Not
say
bad.
that. Sorry?
Not bad.
What?
Because I got the two, number one and number two. Number
Yes.
three, I confused it.
Oh, I see. Okay. All right. We'll talk about him right now. All right. Let me see. Curtis, you made it back? Yes. Curtis is back. Okay. So let's take a look. Somebody want to tell me what they got? What's the reasoning on number one? What do I need? So I know I can write down X and X. What are the two numbers supposed to do?
Add to be n and multiply to be 16.
Yeah, add to be the middle, as long as it's in the right order, right? So you see how that's in the right order? 2x's, 1x, no x's. Add to 10 and multiply to 16. So that one was a nice one to start with, hopefully, right? Not too bad. Of course, the two numbers that do that would be oh, somebody's chatting at me. Yes, Curtis, 8 and 2. So I can put in there x plus 8, x plus 2. It does not matter if you put, no, Jeff. If you put 2 first or if you put 8 first, it does not matter. So that's the answer right there, x plus 8, x plus 2. Now, how do you check it? Well, if you multiply this out, you get x squared plus 2x plus 8x is 10x plus 16. So you do get the answer. You do get, you do get back to where you were. So you can always check your work. Okay, I like it. Oh, Scheisse. Come back. Where'd you go? There you are. Okay. All right. Sorry. Let's see. What about this next one? So again, I know I can write, get in there. I can write x and I can write x because it's x squared. That's the only way to make x squared nicely is with an x and another x. And the two numbers, somebody else tell me, what are the two numbers supposed to do? They're supposed to add to be what?
4 and 8. Minus 4 and put it.
No. Come on, you guys got to listen. You need the two numbers.
4 and 32.
You need the two numbers to add to be 4 and multiply to be, holy macaronis.
8.
Negative 32.
Multiply to be negative 32. All right, I'm not asking for the answer. I'm asking for the thought process.
Okay.
So how did you get to those numbers? You thought, okay, I need two numbers that add to 4, multiply to be negative 32. And you're right, it's going to be, tell me again. Hyam?
4A
Be
minus
a lot
4.
more specific. Are they both positive?
No,
No.
minus 4 and positive 8.
There we go. That's better. Okay. I like it. That's obviously very important, right? If you switch those signs, the middle sign gets wrong. If you make them both positive or both negative, then the 32 isn't negative. Do you guys see that? They have to be different signs. Therefore, when I say add to 4, now I really want you guys to get this. If two numbers are different signs and you add them, you're actually subtracting them, right? Do you guys see that? They have to be 4 apart because they're different signs. I love it. So whenever the last number, in this case, negative 32, whenever that's negative, they will be different signs, and therefore the middle one is going to be the difference between the two numbers. Which one's negative? Well, if the middle term's positive, the bigger one is positive. If the middle term's negative, the big one's negative. So that you end up with a negative when you combine them. So the more you understand numbers, the easier this kind of thing is, because it really does just come down to a number puzzle. What about this last dude? So let me just kind of cut to the chase here a little bit. So you can put down x and x like we know, because they're both, because it's x squared. I need two numbers that add to negative 12, but multiply to be positive 27. So I know they have to be the same sign. Therefore, they will actually add to be 12, then they're both going to have to be negative. Let me stop there for a minute. You guys see the reasoning behind that? Whenever they multiply to be positive, they have to be the same sign. And what sign are they both going to be? Well, they're both going to be negative because the middle term has to be negative. That's the only way to add two things and get a negative. Okay. So what does that? What adds to negative 12 and multiplies to 27?
Negative 3 and negative 9.
Yeah. Get out of there. All right. And that one, you didn't have to do any of the big tricks I was talking about, the like different ways of breaking things down because the numbers weren't very big. I think I have a problem. Yeah, here we go. I have the same problem twice. That's always nice, Jeff. That's always useful. All right, so give these two a try. Don't worry about number 6 because.
Excuse me.
Yes, sorry.
The number 3. How you got the 9 and 3 minus 3 and positive 9? Because here is minus, right?
What says minus? Sorry.
We have to do it minus, right?
What do you mean we have to do it minus? Be more specific. What do you mean?
Like negative is not going to be added. Like 9 and 3. I know when you add 9 and 3 is 12, but we have to do it negative.
No. Are you thinking, so number 2, the 32 is negative. So the two numbers I deal with would subtract to be 4 because they're different signs. Number 3, they are the same sign. What's the only way two numbers multiply to be a positive is if they are the same sign. And if two numbers are the same sign, when you combine them, you truly add them.
Okay, now you add minus 3 and minus 9.
Yep.
Why? Because we have up there is minus and positive, right?
Where's minus and positive? I don't understand.
Minus 12.
Oh,
Positive
all right.
27.
Hyam, tell me, what's negative 3 times negative 9?
Say again, sorry.
What's negative 3 times negative 9?
Negative 9 is 12.
No.
Minus
Negative
12.
3 times negative 9.
Times. I know it's 27. I know that.
Yeah, okay.
But when we have minus and positive, we had to do minus, right? It's gonna be
I'm
nine.
not
or
sure.
it's
No,
gonna
no, no.
be
You
six?
got to be more specific when you say something because I'm not sure what you're referencing. I think you're getting us mixed up with the way we looked at number 2. Whenever the last number is negative, they will have different signs and therefore they will subtract to be the middle one.
Okay, when we have the last number negative,
Yes,
we're gonna do it like number 2, right?
of course. Yes.
Okay, I got it now.
And again, these aren't all things to memorize. You know these things. You just have to recognize them. You just have to go, oh, good, these are helping me. When the last number is negative, then I think about, well, what is 4 apart? That adds to be, that multiplies to be 32, right? Number 3, the last term is positive. They have to have the same sign. Therefore, they actually add when you put them together. So then you
Okay,
have to think that way. What adds to be 12 and multiplies to be 27, 3 and 9? And you
I
just make them
thought-
both negative. Yes.
I thought we have to do it like number 2 because we have positive and negative. Now
No,
I
no, no.
understand.
See, that's the thing. I'm glad you're asking the question because you have to focus on the part of the problem that tells you kind of how to do it. In number 2, it was the fact that the last number was negative.
Okay,
That's what tells me they're going to be different signs.
okay, I got
Number
it.
3, the last number is positive. That tells me they're going to be the same sign. What sign? The sign of the middle.
Okay, I got it.
I like it. I like it. So yeah, you're again. I sometimes it's just not knowing what to focus on. When you're learning something new, you don't know what made us do what. Sometimes you don't know what to focus on. So I appreciate those questions. We want to be really careful about what to focus on. So let's look at get out of the way. Number 4. All right, this one seems daunting, but can you just take a minute, at least write down, everybody should be able to do this. Can you write down what do I need the 2 numbers to do? Don't say it out loud. Don't type it. Just write it down for yourself. I'm going to check it in a minute. All right. So somebody tell me, I need them to add to be what?
-1,
Okay. And I need them to multiply to be what?
-420.
Gather. -420. Okay. Now that sounds daunting, right? I love that word daunting. This is where I would, and 420 has so many factors. Holy crap. If you try to make a complete list of all the factors, you would definitely go a little insane, right? So I'd rather start with, let me ask you this. Do you see how it makes no sense to think they're supposed to add really to be 1? There's no way that 2 numbers can multiply to be 420 and add to be 1. And the reason that it doesn't have to is because what kind of signs? Will the 2 numbers have the same sign or opposite signs? Will the 2 numbers I need have the same sign or opposite signs?
Opposite sign.
Why?
Because the last term is a -1.
Good. The only way you can multiply 2 numbers and have it come out negative is if they have opposite signs. At least real numbers. Don't worry about it. So I'll think about it this way, right? I'll say, okay, I need 2 numbers that multiply by 420. They have to be 1 apart because they're going to subtract to be 1. So then I just give myself some numbers. Let's start off kind of silly without even thinking about it. What about 10 and 11, right? If 11 was negative, does that add to be -1? 10 minus 11. Is that -1? When I combine those 2 numbers, do I get -1?
Yes.
Doing that.
Yes, right? 10 minus 11 is -1. So I've made that condition true, but obviously what's 10 times -11? Right? right? Just put a 0 on 11 because I'm multiplying by 10. That's way too little, right? That's way too small. I know somebody out there knows the answer, but I mean, let's just take a step up. What about 15 and negative 16? You guys see where I'm coming up with this? So I really, you got to get used to the fact that this is just a number puzzle. I know they have to be 1 apart so that when I add them, I get -1. So 10 and 11 are 1 apart, but they don't multiply by everything. 15 and 16. If I make the 16 negative, that's -1 when I combine those. They're 1 apart. This is a much easier thing than trying to factor 420. But what's 15 times 16?
$240.
I like it. Do you see how I'm going in the right direction? You guys see that? I mean, personally, if I'm somebody who's trying to grasp this concept and there's a method that actually the method tells me when I'm going in the right direction, holy shit. So I know I'm going in the right direction. It's getting closer to 420, right? So let's try 20 and 21. If I make the 21 negative, then it makes -1 when I add them, and 20 times 21 is what I want it to be.
420.
Say one more time, sorry.
420, yeah.
Yes, 420, right?
Yeah.
So then that's the one. I made the numbers so that they added to be -1, and then I checked them to see if they also met the other requirement. I need the 2 numbers, and there's only 2 numbers that can do this, that do both things. Once I get those, I'm done. So this is really, the problem is this. This is the problem. Playing with the numbers. And I understand that unfortunately, some of us out there just never got to play with numbers well enough that we're not used to it. And I'm sorry, but at some point you got to start doing that. It's really good if you're able to play with numbers just in general everyday life, believe it or not, but definitely here. So now I know the answer. So this is the great thing about when the first number is a 1, is that once I get the 2 numbers that do what I need them to do, I am done. X plus 20 and X minus 21. Maybe. That's another part that people don't seem to believe, is that that step seems almost too easy. But that's because all the work is in this step here. This is the work. And then the answer is easy after that. Woo! All right, now some of you guys I know have already done number 5, but if you haven't looked at number 5 yet, give it a try. Don't say anything out loud. At least not yet. This one, the numbers might be nice enough to see pretty quickly. All right, let's see. So I can start with this. I can always start with this. X squared, so it's got to be X and X. So then I can focus on just the numbers. That's the one part that I don't know. What are these 2 numbers supposed to do? Add TP. No, there's probably no TP at the store, John. Add to
-3 and multiply to -130.
I like it. So add to the middle term if they're in the right order. Add to the middle term and multiply it to be the last term. Now the last term is negative, right? So like Hayam pointed out earlier, if the last term is negative, then they have to subtract to be the -3 in this case, right? Because when you add 2 opposite sign numbers, they actually subtract. So this one's not too evil. What's the most immediate way to factor 130? Since it ends in 0. I mean, that'll be the first thing I always try. If I see the last number ends in 0, I'm going to try that first. I know I didn't know number 4. I sort of did, and so it was just way off. So 130 is 10 times.
-13.
Yeah, so if you do, so 130 is 10 times 13. I like it. I'm kind of catch up to you. And then if I want to make -3, the bigger one's negative, and it does make -3.
Yes.
Yes. So I like to say, rule out the easy answer. Try the easy answer first. If it doesn't work, then you go, oh shit, I got to really do this now. But try the easy answer first and see if it works. And in this case, yeah, it does. I'm done. I just got to put the, so I'm going to do it the other order this time just to show you. -13 plus 10. Doesn't matter which one you really do first. Okay, I like it. And you're all done with number 6 now. Yay! All right, and these two real quick. Let me see who remembers. I want to have a little bit of time. Well, let's see. I don't know if I'm going to have any time for this other thing. What do I do with number 7?
Pull 5 out.
Yeah, in fact, now to be honest, the first thing you always try is GCF, but each one of these had a 1 at the beginning. There's nothing that coming out. And the last term had no X's. So I didn't even point this out, but you should always check GCF first. Just see if it'll work before you start, because right now I can't do this. We haven't learned how to handle it if the first number is not a 1. And thank God, like Jamie said, a 5 will come out. If it'll let me write. Okay. So what's left inside when I take a 5 out? I'll have x squared plus 5 goes into 20 4 times, and then I'll have 5 goes into 15 3 times, right? That's the good old GCF. You gotta like GCF. The more factoring we learn, the more you will like GCF, I think. Now, do you see how the inside is a trinomial with the 1 at the beginning? So now I can try to do that. I just write this again. The 5 comes for the ride. And then I can write x. And what 2 numbers do I need? I need 2 numbers that multiply to be 3 and add to be 4. That kicks ass. What's the only way you can make 3? What 2 numbers? Or the only nice way to make 3. One times 3. And what's 1 plus 3? Yeah, so you need 2 numbers. Forget about the 5. 5's outside. It's done. It just comes for the ride. Inside, I see a 3 at the end. I need 2 numbers that multiply to be 3 and add to be 4. Thank God the only 2 numbers that multiply to be 3 also add to be 4. So that's it. 3 is 3 times 1, and 3 plus 1 is 4, so that's the answer. Plus 3 plus 1. So I don't know. Sometimes I think it's, sometimes people are not good with playing with numbers. That'll always mess you up. Or people don't trust what I'm saying, that it is just a number puzzle. And once you get the number puzzle worked, you're done. Because then the point of the number puzzle is to figure out what the 2 numbers are, and you already know what's at the beginning of each one. So once you get the numbers, you're done. Okay. Now, what about number 8? I'm sorry. Oh, Veronica, number 6 is the same as number 5. It's whoever made this sheet. I don't know. Some guy named Jeff. For some reason, just put the same problem down again. Do you see that? So once we did number 5, we did number 6 because it's the same problem. What about number 8? Take a minute. Don't say anything. You need 2 numbers that do what? multiply to be
18 and add to be 3.
yeah, they have to be the same sign, right? Do you see that? There's no way two numbers add to be 3 and multiply to be 18. There's no way. 1 plus 2 is 3. 0 plus 3 is 3. There's no, they have to be positive, actually. There's no way to do it. 1 and 2 add to be 3, but they don't multiply to be 18. Now, let me ask a really weird question. So right now, the way this is written, this is prime. Don't forget that is a valid answer. Just don't overuse it. How can I rewrite this problem? So this problem is done. It's prime. We're done. How would I rewrite it so that it's doable? I can make this x squared. Now watch this. Plus 3x. If I made this minus 18. Who's doing something? Be quiet. I pull out my Gordon Ramsay. Be quiet. All right. And then why can I do this problem? I can do this one. If I make the 18 negative, I could do it because now I need two numbers that multiply by a negative number. So now they actually subtract. What two
3 and,
numbers? Yeah.
3 and 6.
3 and 6, right? It's doable.
And then negative 3.
And the bigger one's got to be positive. I like it. So that the middle comes out positive. So that's doable. Do you guys see that? All it took is that one little change and it's doable. I just realized something I want to do now. Watch. You guys are going to love this one. Oh yeah. Oh, that's a good intro. I'm surprised nobody went running after I said that. That problem. So again, this original problem is prime. Once you write prime and circle it, you're done. I just asked an extra little question. What could I change in this problem, make it doable? Well, if I make the 18 negative, it allows for the two numbers to be opposite signs. So then they can subtract to be 3, not add to be 3. So it is all about understanding how numbers play with each other. So now watch this. Let me see. Let me take one. Let's take this first one. I'm not sure I'm going to write this. What should I get if I do x plus 8? Oh, shit. This is going to look gross, but too bad for all of us. And divide that into. Really, Jeff? You have to bring back long division? Yeah. What should I get if I divide that into x squared plus 10x plus 16? You know the answer. You already know what the answer is supposed to be. What do you get when you divide 35 by 7? What's 35 divided by 7? What's happening out there? What's 35 divided by 7?
5.
Okay. It has nothing to do with this problem, right? I don't know if that's what's tripping you guys out. It's just a side note. Why is 35 divided by 7 5? Because 5 times 7 is 35. So x plus 8 times what is x squared plus 10x plus 16? X plus 2.
2.
X plus 2.
8. 8 plus 2.
Are we starting to play a football game? Hold on. Stop. No 2, 8 hike. What does this say right there? What did we figure out on number 1? We figured out that x plus 8 times x plus 2 is what makes x squared plus 10x plus 16. Isn't that what we figured out? That's what we wrote down. We broke up x squared plus 10x plus 16 into 2 pieces that multiply to become it. So everybody cool with what I just said? That's what we did. Therefore, x squared plus 10x plus 16 divided by either one of them equals the other one. Isn't that how numbers work? If 5 times 7 is 35, then 35 divided by either one is the other one. 35 divided by 5 is 7. 35 divided by 7 is 5. Do you see what I'm saying? So if I know that 2 things multiply to be something, then that something divided by one of the things is the other thing. We know that. We know that. So I know what the answer should be up here. It should be x plus 2. So let's see what we get. Just to remember how to do this. X times what is x squared? X. X times x is x squared. Get in there. Get in there. So x squared. X times 8 is 8x. And then I change the signs. There's no pretty way to do this. Sorry. All right. And then if I do this, these cancel. 10x minus 8x is negative 2. Get out of there. Negative 2 is 2x plus 16. X times what is 2x? 2. 2 times x is 2x. 2x, Jeff. And 2 times 8 is 16. And then when I subtract those, I get 0, right? They cancel, right? Do you guys see what I'm saying? So, of course, yeah, we knew that was going to happen. It's just kind of nice to bring everybody understand what just happened. So if I change these guys' signs, right? So that when I add them, they become a negative. They cancel. So I get no remainder, which means it went in evenly. This times this is this. And we knew that. So if you do that with any of these other ones, it would work the same way. Do you ever actually have to do that? No. So why did I do it? Because it's a nice review of long division of polynomials, and it's a reminder that variable expressions are numbers. So they act the same way as numbers do. Okay. Let me see. All right. We got like 5 minutes. I'm not going to try to shove all this in there, but yeah, this is a big discussion. It's not even good to like do a little piece of it. So it might be good. This is, let me make sure this is true what I'm about to say. Hey, everybody. Let me see. I think I put this, did I actually get it done? Yes, I did. That's right. So watch, let me share this back with you guys. Become a thing. Okay. So if you go to math, if you go to 90, and you go to pages, and you see this where it used to say handout on 7.2, now it says handout on 7.2 and 7.3. So that one we were just looking at is right there. And the reason it's got this weird title is because it's factoring where A is not equal to 1. That's what's on the other side. So the first side we just did was a review of 7.2. The second side that we didn't get time to get to is 7.3, is the idea behind 7.3. So it'd be a really good idea to just take a quick look at it. If you don't, it's okay. We're going to go over it tomorrow, starting from scratch. No worries. But if you get a minute, it's not a bad idea to take a look just to be ready. All right. Let me see. Who's still awake out there? Anybody have any questions? I know I'm a math teacher. I'm used to.
No,
Is
thank you.
7.3 due tomorrow then, or you'll teach it to us tomorrow and we'll do it tomorrow night?
So look at the sheet if you have time. And if you don't have any time to look at the sheet, we will do it tomorrow together. So it's not due, it's just there for you to look at. Does that make sense?
Yes.
Okay. All right. Anybody else have questions?
No, thank you. Bye-bye.
Okay. If you don't have questions, you could head out. Thank God, right? My God, get me out of this place, right? Oh, geez. All right, I'm going to watch your pop up, pop up, pop up. Let me see who's not really here. Are you guys here? No? Oh, I got 2 new messages. Oh, Curtis and Abby say bye. All right. The rest of you guys, I'm closing the room.
Bye.